welcome to this explainer. Today our goal is completely demystifying the SASB energy management standard that's specifically designed for water utilities. We're going to break down these quantitative energy management metrics step by step. By the end of this explainer, you'll understand exactly how water utilities calculate and report their total energy consumed in gigajoules, the percentage of grid electricity used, and the percentage of renewable energy consumed. It's a really fascinating look into the strict accounting mechanics of sustainability, so let's just get right into it.
Okay, let's dive into this with a quick roadmap of what we're covering today. First, the water energy nexus. 2. Introducing metric IFW 130A.1. 3. Total energy consumed. 4. Percentage grid electricity. 5. Percentage renewable energy. And 6. The bottom line.
Section 1. The water energy nexus. Why energy matters in water services. Before we get into the accounting math, we really have to understand the macro problem here, which is that water utility companies consume staggering amounts of physical energy, which brings us to a critical question. Think about a water utility's balance sheet for a second. What is their largest operating cost after you factor in purchased water, labor, chemicals, and basic utility operating costs? Well, the answer is energy use. Moving and treating water is just an incredibly energy-intensive process. It's the heavy physical work of withdrawal, conveyance, treatment, and distribution. And historically, the main energy input doing all of this heavy lifting has been purchased grid electricity.
And that reliance brings us to a core issue highlighted right in the SASB standard. To quote the document directly, the inefficient use of purchased grid electricity creates environmental externalities, such as increased Scope 2 greenhouse gas emissions. This perfectly establishes the stakes. Depending heavily on an inefficient, fossil fuel-heavy public grid isn't just bad for greenhouse gas emissions, it leaves utilities totally vulnerable to future price hikes driven by evolving environmental regulations.
Section 2. Introducing metric IFW 133A.1, the SASB standard. So, how exactly do investors and stakeholders track a utility's transition to cleaner sources? Well, the solution is this specific accounting standard.
Now, what's really interesting about this slide is how it simplifies things. Looking at the energy management row, you'll find metric code IFWU 130A.1. It essentially takes this massive, complicated issue of energy use and distills it down into 3 really convenient quantitative pillars: total energy consumed, percentage grid electricity, and percentage renewable. Let's explore exactly how a utility calculates each one.
Section 3, total energy consumed, the core measurement. Moving to the first pillar of our rule of 3. Obviously, before you can figure out your percentages of green or grid power, you have to calculate the aggregate amount of energy consumed.
And to ensure we're getting apples-to-apples comparisons across the entire industry, all reported energy data has to be converted into a single unit of measure, gigajoules, or GJ. To get there, utilities apply specific conversion factors. For example, if they're measuring consumption from fuels and biofuels, they use higher heating values, or gross calorific values, either measured directly or taken straight from the IPCC. But what exactly goes into that gigajoule calculation? The scope is strictly defined. It includes purchased external energy, self-generated energy, direct fuel usage, heating, cooling, steam, and literally all water, wastewater, and stormwater operations. However, there is a very strict boundary here. It only includes energy directly consumed by the entity during that specific reporting period.
Section 4. Percentage grid electricity, measuring grid reliance. All right, once you have that massive gigajoule number for total energy, we move to the second pillar of the metric.
The math here is beautifully straightforward. To find the percentage of grid electricity, you simply take the purchased grid electricity consumption and divide it by the total energy consumption we just calculated. It's basically visualizing grid power as one slice of the total energy pie. Tracking this specific slice year over year helps everyone understand the utility's exposure to grid reliability issues and changing prices.
Section 5. Percentage renewable energy, the rules of green power. Now we transition to the third, and honestly the most complex pillar. You really have to pay attention here, because the accounting rules for what legally counts as green power are incredibly strict.
First off, the basic formula is identical to the grid calculation: renewable energy consumption divided by total energy consumption. But what actually counts as renewable? Well, the standard defines it as energy from sources replenished at a rate greater than or equal to their depletion, things like geothermal, wind, solar, hydro, and biomass.
So the crucial point is understanding the gotchas in this accounting. You can't just slap a solar panel on a roof and claim it.
For instance, if you generate renewable electricity on site, but you sell the renewable energy certificates, the RECs, well, you lose the right to claim that energy is renewable. It absolutely does not count. Also, you cannot count the renewable portion of the standard grid mix if it's outside your direct control. And for biomass, it has to be third-party certified by groups like the Forest Stewardship Council.
Now, if a utility purchases green power, it usually happens through a power purchase agreement, or PPA. But not just any PPA counts. Let's walk through the exact criteria. Step 1, the agreement must explicitly include and convey RECs or guarantees of origin. Step 2, those certificates must be retained or replaced. And Step 3, they must be retired or canceled on behalf of the entity. Basically, you have to lock those certificates away so literally no one else can claim them. Only then does it actually boost your renewable percentage.
Section 6, the bottom line, future risks and realities. To wrap up our explainer today, we need to bring all this technical math back to reality. Why create such strict pillars for energy management?
And this brilliantly illustrates the cyclical trap utilities are caught in. Climate change is expected to drastically affect water availability. As traditional fresh water becomes harder to access, utilities are forced to turn to alternative treatments like desalination and water recycling. The catch? Those alternative treatments require significantly more energy. So as water gets scarcer, the energy intensity goes up, creating a massive challenge for cost control and sustainability.
So what does this all mean? It leaves us with a pretty provocative question. As climate change continues to threaten water resources, how are utilities going to balance the absolute need for more intensive water treatment with the push to lower their energy footprint? Understanding SASB metric IFW 13A.1 gives us the exact mathematical lens to watch how utilities attempt to solve that puzzle. Thanks so much for joining me for this explainer, and I hope this changes the way you think about the relationship between the water from your tap and the energy on our grid.